Hey everybody, this is Mrs. Wilson. Today we're going to be looking at section 9.5 in your book, Inverse Functions. This is taking the place of our second EDay. So upon following this video, you should open your assignment and complete that and turn it into your teacher. Remember that you can pause or rewind this video at any time if you get stuck or you need to take a few more minutes. I promise to keep this shorter than the last one. Okay. In our last lesson, we learned about functions and specifically composite functions, how we add, subtract, multiply, and divide functions together, and then also what happens when we plug one function into another. So following that, we're going to be talking about specific types of functions, and those are inverses. So let's start first with what inverse functions are. Well, graphically, if we look at inverse functions, what we see, let's draw an example of a function. Okay, there we go. That's like a cubic function maybe. Inverse functions are reflections across the line y equals x. So if I were to take a mirror image and flip this function over this line, what would it look like? Something like that. This bottom function represents my inverse function. Okay, and notice I labeled it differently. Okay, this notation right here, let me write it a little bit bigger for you. This notation is going to stand for the inverse of a function. I have my parentheses in the wrong place there. Alright, so a lot of people get this confused and you see it and you think, oh, that's a -1 exponent, so I need to flip it and move it to the bottom. No, when you see this little -1 right up above the f with the x over here, that's talking about the inverse. So we start with our function. Once we reflect it, we get the inverse function. Alright, so graphically you can see what it means. Now, what this also means with regards to x and y is that the x's and y's are swapping positions. So for example, if this intercept right here is 0, 2, then when I reflect it, notice that this point becomes 2, 0. So what happened? My x and my y switched positions. And that always happens with inverse functions. So your domain, remember, represented by your x's, and your range, represented by your y's. In inverse notations, those flip around. One of the questions we'll have you do in your assignment is I will give you a list of just relations. So for example, 1, 3, 2, 7, and maybe 4, -6. Alright? This represents our initial function, and I will ask you to name the inverse relation. All you're going to do is swap your x's and your y's, because once again, when I reflect it over that y equal x, that's what happens. So 3, 1, 7, 2, -6, 4. It's as easy as that for part of the homework. Alright, algebraically speaking, what we see is that inverse functions undo each other. For example, if I had a function that was represented by 3 times x, when I think about the inverse operation, this is a multiplication, the inverse operation would be division, and so my inverse function would be represented by x divided by 3. Okay. Now, specifically, what we see when we use our composition functions is that when I plug an inverse into the function, everything cancels out except for the x, and vice versa. When I plug a function into its inverse, everything is going to cancel out. All right. So we use what I like to call those fog problems to test to see if we indeed have functions. And it will work both ways. So let's use these two examples to show how we would algebraically prove that we are working with inverses. Alright, so remember with composite functions, we start with the left. We're going to call this g over here. We're going to pretend we don't know this is the inverse. And I'm going to plug this into my f function. Alright, so instead of x, I'm plugging in the g function. So in place of x goes x over 3. Now notice my 3's divide evenly into 1 or cancel out, and I'm left with just an x. That always happens with inverse functions. Let's go the other direction. So this time I'm going to take my f function and plug it into the g function. So I'm taking 3x and I'm plugging it in right there. Again, notice that my 3's cancel out and I'm left with an x. So another type of question that you will be asked is to determine whether a pair of functions are inverse functions. So let's do one example of that. Alright, here are two functions. I want to know, are they inverses of each other? They kind of look like it, but I'm not sure. So I'm going to show algebraically, or I'm going to check algebraically and see if they are. So that means I'm going to do a composite of g and h, and then I will go in the opposite direction and do h at g. So let's start with g of h. We'll do this right here. Alright, we're going to take the h function and plug it into g. So in place of the x, I'm putting the entire h function. And what I'm looking for is that everything is going to cancel out or undo each other, and all I'll be left with is an x. Okay, so I need to distribute this 13 here. It's going to give me 13 over 13x minus 13 minus 13. X minus 26. Okay, notice it didn't cancel out. Alright, so actually I can stop right here and say, no, these are not inverses. Because in order to be inverses, I would have had to have got a single x. Let's do one more, and I'll show you what it looks like when they are inverses. Alright, so same question here. I want to check to see if these two functions are inverses of each other. So I'm going to start by doing a composite of g and h. Alright, so that means we're taking the h, the entire h function, and plugging it into g. So in place of that x, I'm putting the h function right there. And we're looking to see if all of the operations are undone. So this is going to give me a 2 over 2x plus 8 minus 8, which equals x plus 0, which equals x. So that worked. Let's go in the opposite direction just to make sure. Right now they look like they are inverses. Opposite direction. This time we're going to take the g function and plug it into the h. Over 2x minus 4 plus 4. Everything cancels except for x. So what we're saying is that g of x and h of x are, in fact, inverses. If we were to graph them, they would be nice reflections across that diagonal line at y equals x. Alright, the last type of problem we will ask you to do is to actually find the inverse. Given one function, can you find its inverse? So here are the steps for doing it. Number one, you're going to replace your function notation with a y. Then you will swap the x and the y, because remember with inverses, that's what's happening. The domain and the range are changing positions. That's what happens when we reflect it across that y equals x line. Then we're going to solve for y, and your last step will be to replace that y with inverse function notation. And then you're finished. So let me show you one example of that, and we will be done. I'm going to use g of x, but just remember you can do really any h of x, f of x. It's not always f of x. Alright, so let's do this example. I want to find the inverse. Step 1, replace our function notation with y. Step 2, swap the x and the y. So I keep everything the same, I'm just changing the positions of my x and y. Step 3, solve for y. I'll subtract 3 from both sides, and then divide everything by 2. Last step, replace the y with our inverse notation. So this is not the original function anymore, this is the inverse of g. and you are done. You found the inverse algebraically. So you've got one assignment. It's worksheet 9.5. You can download that PDF, print it off, and turn it into your teacher. If you have questions, make sure to check with us. Any of us can help you out. Thank you.